Have you ever gazed upon the moon and wondered why it has so many faces? A question that has sparked curiosity in the minds of humanity for centuries. This celestial body, hanging in our night sky, is Earth's only natural satellite. It's our closest celestial companion, a silent observer that has watched over us since the dawn of time, always changing, yet ever constant. The moon's faces, as we like to call them, are not actually faces at all. This is a term we use to describe the different phases of the moon, the shifting patterns of light and shadow that we see from our vantage point here on Earth. From the slender silver crescent of the new moon to the bright full face of the lunar disk during a full moon, these phases are a result of the moon's orbit around our planet and the angle at which sunlight hits its surface. But the moon is far more than just a changing pattern of light and shadow. It's a world in its own right, with a history and a geology as complex and fascinating as our own. Over the course of this series, we're going to delve into the moon's many mysteries. We'll explore its rugged surface, pockmarked with countless craters from billions of years of meteor impacts. We'll journey into its interior, where seismic activity hints at a dynamic, still active core. We'll venture to its poles, where ice caves hold the tantalizing promise of water. And we'll investigate its motion, the intricate dance of forces that keeps it locked in its orbit around our planet. So, join us on this lunar expedition. Let's set out together on a journey of discovery, a voyage of understanding about this familiar, yet enigmatic celestial body. But what creates these faces? What lies beneath the moon's surface that shapes its appearance? Stay tuned as we uncover the answers to these questions in the following scenes. Let's unravel the mystery of the moon together. At first glance, the moon appears to be a barren grey rock, but look closer and you'll find a world of intrigue. As we shift our attention to the moon's surface, we see a landscape that's been shaped and molded by the forces of the universe. It's a place of extreme contrast, with towering mountains, deep valleys, and countless craters scattered across its terrain. The moon's surface is a testament to its tumultuous past, a past that's etched into every inch of its scarred and pockmarked face. Let's start with the craters. These are the most recognizable features of the moon's surface. Formed by the impact of asteroids and comets, these craters range in size from tiny pits to colossal basins. Some, like the famous Tycho crater, are surrounded by intricate systems of rays, lines of debris that were thrown out by the impact. Others, like the enormous South Pole Aitken Basin, are so large they can only be fully appreciated from space. The moon's mountains and valleys tell a similar story. The lunar highlands are peppered with towering peaks, some of which rival Mount Everest in height. These mountains are the result of ancient impacts that have thrust the lunar surface upwards, creating jagged skylines that stretch as far as the eye can see. And then there are the valleys. Lunar valleys, like the Valles Schroetteri, are often associated with the moon's vast system of rills, long, narrow channels that snake their way across the lunar surface. These rills are thought to have formed through a combination of volcanic activity and tectonic forces, carving out valleys and canyons that add yet another layer of complexity to the moon's surface. Each of these features contributes to the moon's many faces. They reflect the moon's dynamic history, a history of violent impacts, volcanic eruptions, and tectonic shifts. They're a record of the moon's past, a past that's as fascinating as it is mysterious. The moon's surface is a testament to the forces that have shaped it. But what about what lies beneath? Beneath the moon's surface lies a realm of mystery and fascination. Deep under those familiar craters and maria, the moon harbors layers that tell a tale of its history and formation, and these layers significantly contribute to its overall appearance. Let's start with the moon's outermost layer, the crust. It's a rocky exterior, about 38 miles thick on the side facing us, and thicker on the far side. This crust is pockmarked with countless craters, formed by billions of years of meteor impacts, which give the moon its distinctive scarred facade. Beneath the crust, we find the moon's mantle. Now, this isn't a cozy layer of warmth like the mantle of a fireplace. It's a thick layer of silicate rock, extending nearly 1,000 miles towards the moon's center. The mantle is essentially the moon's engine room, driving its tectonic activity. As the mantle cooled over billions of years, it caused the moon's surface to contract and crack, forming the network of cliffs and trenches we see today. Finally, at the heart of the moon lies a small, iron-rich core. This core, though tiny compared to Earth's, is still significant. It's roughly 400 miles in diameter. Despite its size, the core doesn't contribute much to the moon's magnetic field, a stark contrast to Earth. Each of these layers, the crust, mantle, and core, plays a part in shaping the moon's appearance. The crust gives the moon its rugged, cratered surface. The mantle's cooling and contraction have sculpted the cliffs and trenches. The core, while largely silent in the moon's magnetic tail, is still a crucial part of the moon's identity. The moon's interior is more than a static, inert mass. It's a dynamic system, whose processes have shaped and continue to shape the moon's face. It's these internal structures that give the moon its character, its personality, and its allure. The moon's interior plays a significant role in its appearance. But what about the icy poles? Let's delve into that in our next segment. The moon's poles are a world apart, harboring ice and offering a glimpse into the moon's past. Now, I know what you're thinking. Ice on the moon? Well, that's precisely what scientists discovered a few years ago. It all started when satellites sent to orbit the moon detected hydrogen signatures. This was a big clue, because where there's hydrogen, there's a good chance of finding water. And sure enough, subsequent missions confirmed that there was indeed water ice at the moon's poles, particularly in permanently shadowed craters. These icy patches are believed to be remnants from comets that crashed into the moon billions of years ago. This discovery of water ice was a game changer. It not only told us more about the moon's history, but also opened up a whole new world of possibilities. For one, it shifted our perception of the moon from a dry and barren wasteland to a place that could potentially support life. Not in the same way as Earth, of course, but enough to sustain human exploration or even colonization in the future. The presence of ice also indicates that the moon's poles have a more stable environment than other parts of the moon. Unlike the equatorial regions, which swing between extreme heat and extreme cold, the poles maintain a steady, if frigid, temperature. This makes them ideal locations for future moon bases. But it's not just about the practicalities. The discovery of ice has also given us a deeper appreciation for the moon. It's a reminder that even a place as familiar as the moon can still surprise us. That it's more than just a pretty face in the night sky. It's a complex world with its own story to tell, a story that we're only just beginning to understand. While the moon's poles add another layer to its many faces, the moon's motion also plays a pivotal role. The moon is not a static object in our sky, but one in constant motion. This celestial body, our closest neighbor in the cosmos, is constantly on the move, showcasing a fascinating dance of rotation and revolution. Let's break that down a bit. The moon rotates on its axis, much like the Earth. This rotation, however, is synchronized with its revolution, the moon's orbit around the Earth. This synchronization, known as synchronous rotation, is why we always see the same face of the moon from our perspective here on Earth. It's like a cosmic ballet, where the moon is the dancer and gravity is the choreographer. Now, this dance of rotation and revolution brings about a fascinating spectacle, the lunar phases. As the moon orbits the Earth, the angle between the moon and the sun changes, resulting in different amounts of sunlight falling on the moon's surface. This causes the moon's appearance to change over the course of a month, from a thin crescent to a fully illuminated full moon, then back again. This is a cycle as old as time, a rhythm set to the beat of the cosmos. But what does this mean for the faces of the moon we see from Earth? Well, while we always see the same side of the moon, we don't always see it the same way. The changing lunar phases present us with different faces of the moon. Sometimes it's a thin sliver of light in the twilight sky. Other times it's the familiar full moon, bathing the night in its silvery glow. The moon's motion is a testament to its dynamic nature. It's not just the static, unchanging sphere we might imagine it to be. The moon is alive with movement, a constant companion in our night sky, its face changing with the ebb and flow of its cosmic dance. So, the next time you gaze upon the moon, remember its many faces, a testament to its complex and fascinating nature.